Today, lesson 34C, 0 and negative exponents. Day number 1, we will spend one more day on this, but today's day number 1 of this idea. We've talked in full detail about expressions that have positive exponents. We've talked about multiplying and dividing and power to a power and problems with multiple bases and so on. And we will eventually get to all of those ideas with negative exponents as well. So here we go. We can think of powers of 2 as representing multiplication of the number 1 repeatedly. So what I mean by that is this. We can think of 2 to the 4th power as 1 times 2 times 2 times 2 times 2. Fill that in, please. Because if I multiply something by 1, it doesn't change its value. And we have a property for that we talked about earlier in the year. And 2 to the 3rd, of course, is 1 times 2 times 2 times 2, which, of course, is 8. And 2 squared, of course, is 1 times 2 times 2, which is 4. And 2 to the 1st is just 1 times 2. Now, what I'm trying to do here is I'm trying to get you to see the pattern as the exponents keep decreasing, right? There's a specific pattern going on here. So based on that pattern, what do you think 2 to the 0 power is? 1. It's 1. Because it is 1, all right? And as we go from 2 to the 4th to 2 to the 3rd to 2 to the 2nd to 2 to the 1st, we can think of it as dividing by 2 or multiplying by 1/2. To go from 8 to 4 or 2 to the 3rd to 2 to the 2nd, we can think of that as dividing by 2 or multiplying by 1/2. And the same thing as we continue to decrease the exponent by 1 each time. So now, based on that, or the fact that we know that 2 to the 0 power is 1, what do you think 2 to the negative 1 power is? And usually somebody will say, negative 2. Well, if you think it's negative 2, it's not following the pattern. And secondly, it can't be negative 2 because the base is not negative. So what is it? It's 1/2, exactly. Because 1 divided by 2 is 1/2, or 1 times 1/2 is 1/2. And so the pattern would continue as we continue to decrease the value of the exponent by 1. So what is 2 to the negative 2 power? 1/4. Very good. And I'm showing you the intermediate step there. I'm showing you why it is 1/4 right here. Because it's really 1 over 2 squared. All right, and then 2 to the 3rd, of course, would be what? Tell me, please. 1/8. It's 1/8. Good. And there's the reason why. And what's 2 to the negative 4 power? 1/16. 1/16. Good. Okay, so hopefully you kind of see what's going on with negative exponents, and even 0 as an exponent for that matter. And so if positive exponents indicated multiplying the number 1 by 2 repeatedly, then negative exponents should indicate dividing by 2 repeatedly or multiplying by 1/2. Okay? All right. So, quick comparison. What's 4 to the 2nd power? Tell me quickly. 16. What's 4 to the negative 2 power? 1 over 16. Good. What's 3 to the 3rd power? 27. And there were a few of you who knew that one in your head, then 4 to the 2nd. But by the time we get through with all this exponent stuff, you're going to have so many of these memorized. Obviously, I'm going to ask 3 to the negative 3. What's 3 to the negative 3 power? 1/27. Good. And hopefully you see the relationship there. We already know 2 to the 4th is 16. 2 to the negative 4 is 1 over 16. What's 5 to the 2nd? What's 5 to the negative 2 power? 1 over 25. Okay? All right. I would like all of you to do 2 through 7. Sorry, 2 through 5. 2 through 5. All right, so here's what you should have come up with. Number 2 is 8. 2 to the negative 3 power is 1/8. Number 3, 8 to the 2nd is 64, but 8 to the negative 2 power is 1 over 64. Number 4, 3 to the 4th is 81. So 3 to the negative 4 power has to be 1 over 81. Number 5, 7 to the 2nd is 49. So 7 to the negative second power has to be 1 over 49. So we kind of got the basic idea of negative exponents. It does get a little more complicated, but we've got the basics down. So continuing on here, we want the pattern of positive integer powers to extend to 0 exponents and negative integer exponents. We can now define 0 and negative exponents as follows. And this is already in your notes. So the general definition for 0 as an exponent is this. B to the 0 power equals 1 as long as b does not equal 0. So what that means is this. That means any number to the 0 power is 1 except 0 to the 0 power. Okay? So I guess my next question to you is, what is 0 to the 0 power? Some of you will have one idea, some of you may have something else, and there have been discussions for many years about what 0 to the 0 power really is. And in case you're curious, when you get home tonight, Google it and see what you come up with. Okay, you will see one of two different things. And then the official definition for negative exponents, b to the negative n power is 1 over b to the n power, where, once again, b is any number other than 0. Okay? All right, quickly, do 6 through 10. All right, so tell me, number 6 is? Tell me. Try that again. What is it? It's 1. What's number 7? Let me catch up here. What's number 8? Uh-oh. Yeah, I heard about half 1 and half negative 1. Which one is it? It's negative 1 because the negative 8 is a base without without parentheses around it. So therefore, when the base is negative without parentheses around it, it doesn't matter what the exponent is, the answer will be negative. So that is actually negative 1. Number 9, tell me please. 1. Number 10? Negative 1. Very good. All right. 11 through 15. I'll give you about 20 seconds. And here is obviously what we should have. Number 11 is 1. Number 12, much like that negative 8 to the 0 power on the previous screen, is negative 1. 13 is 1. 14, it doesn't matter what that simplifies inside the parentheses because we will still get an answer of 1. And then number 15 is negative 1. All right, continuing on. Here's what I would like you to do. I would like you to do, with your shoulder partner, 16 through 30. 16 through 30. I'll get back to you in a couple minutes. All right, so as we quickly saw, most of these are pretty easy. Number 16 is 1 over 16. By the way, if we were asked to write in exponential form, then we would stop at 1 over 4 squared, but we are asked to evaluate here. Number 17 is 1 over 36. 18 is 1 over 8. 19 is 27. We have a positive exponent there. 20 is 1 over 125. 21, another positive exponent there, so that one is just 64. And I asked you to go through number 30, so let's continue on here. Number 22 is 1 over 16. Here's the reason why it's 1 over 16. Because negative 4 to the second power, where the base is in parentheses, turns into 1 over negative 4 squared, and that is 1 over 16. Number 23, similar problem. That should be 1 over 36. Number 24 is negative 1/8. Now the reason why the solution is negative is because in the denominator we have a negative times a negative times a negative. We have an odd exponent, so we should have known that that was going to be the case. Continuing on, number 25 should be negative 125. The exponent was positive. Number 26, the exponent is negative, so something different happens here. That starts off like this, that turns into negative 127. Number 27 should be 1 over 81, and there's the reason why. 28 should be 1 over 64. Here's the reason why. 29, a positive exponent. So that's just a regular problem. Negative 32. And then number 30 is 36. Now, before I have you finish the rest on this page of your notes, or this side of your notes, I want to take a look at number 31 together. Anybody have any idea what that simplifies to when we evaluate it? Yeah.
Negative 1 over 81.
So why is it negative when we have an even exponent?
Because it doesn't have a parentheses around it.
Around the negative base. Exactly. And that's the thing that we have to remember, because remember, here's what this really is. This is really the opposite of 9 to the negative 2 power. That's what we have to remember when the base is negative and we don't have parentheses around it. So this 9 to the negative 2 power is 1 over 81, and so that's the reason why it is negative 1/81. Okay? All right. With your shoulder partner, finish off this side of your notes, and then we'll go to our last idea for today.
32 would be negative 1 over 600.
The fourth power equals 1 over negative 1 over 5 times 5 times 9. 125 times 5.
Number 32 should be negative 1 over 625, and that's the reason why. Number 33 should be 1 over 49, and that is the reason why. I'm showing the intermediate steps on how we get there. Number 34 should be negative 1/27th, and that's the reason why. Number 35 is negative 1/32nd, and you can see by the intermediate steps why. Number 36 is negative 8. 37 is negative 64. Number 38 is negative 36. 39 is negative 1/81st, and that's the reason why. 40 is 64. 41 is negative 343. I think that's now the 5th time we've seen this 7 to the 3rd power over the last few lessons. Number 42 is negative 1/216th, and that's the reason why. 43 is negative 1/256th. Number 44 is 729. 45 is negative 1 over 512. 46 is 1/16th. 47 is 625. And number 48 is negative 1/243rd. Any questions through number 48? All right, so the last idea is what happens if the base is a fraction? Well, we're going to try and attack this the same way, trying to see a pattern. So let's think of 9 to the negative 2 power like this. We already know it's 1 over 81, okay? But what if we take a look at it like this? 1 over 9 over 1 squared. Just by utilizing the basic definition of a negative exponent, okay? Because that's what it is, remember? Negative exponent I gave you look like this. B to the negative n power is 1 over b to the positive n power. That's all that I did, because really 9 is 9 over 1. Okay? And so now, if I figure that out, I have 1 divided by 9 over 1 squared, which is 1 times 1/9 squared, and that is 1 over 81. And so if we sort of think of all of the fractional base problems like this, it will be easy to figure out exactly what's happening. Okay? All right. So let's take a look at number 49. 2/3 to the negative 2 power. So if I utilize what I just talked about, that is the same thing as 1 over 2/3 to the positive 2 power. And obviously, you should be taking good notes. Well, that means 1 divided by 2/3 squared, which is 1 times 3/2 squared. And that is 9/4. So number 50 looks like this. I didn't mean to click that. 4/5 to the negative 1 power. Anybody know what that's going to turn into?
1 and 1/4.
1 and, well, let's leave it improper.
Okay, 5/4.
5/4. Very good. It'll be 5/4 to the first. Intermediate steps will show me that it's 5/4 to the first, which is just 5/4. Okay? All right, can I get everybody to do number 51 and 52? All right, let's see what we have here. Jessica, what'd you get for number 51? 16/9. Now, if you're asked to write it in exponential form, you would say that it's 4/3 to the positive 2 power. We typically in math don't leave things with negative exponents. So it is 16/9. Okay? Claire, number 52.
16.
It is 16. Good. It turns into 4/1 to the second power. And 4/1 to the second power is 16. All right. Finish them off with your shoulder partner. I'll get back to you in a few minutes. Number 53. We're trying to get to the point where we can see that negative 1/3 to the negative 2 power is the same thing as negative 3/1 to the positive 2 power. Because then we can clearly see that when we evaluate it, we get 9 for this one. We're trying to get to the point where we can see that negative 3/5 to the negative 3 power is the same thing as negative 5/3 to the positive 3 power. And that is negative 125/27. Number 55. Of course, we're trying to see that that's the same thing as negative 5/4 squared, which is 25/16. We're trying to see in number 56 that that is the same thing as negative 8/3 squared, which is 64/9. 57. We're trying to see, never mind, that's already a positive power, so we don't have to worry about that one. That's 4/49. Number 58, negative 6/7 to the 0 power. That negative 6/7 is in parentheses, so therefore that is 1. 59, we are trying to see that that is the same thing as 6/1 squared, which is 36. Number 60, we have a positive exponent. Don't get that mixed up with negative exponents. This one would be negative 8/125. 61, we're trying to see that that's the same thing as negative. Dumped a negative there. This should really be negative right here, which makes that negative 8/27. And then the last one, of course, this will be negative 1/125. All right, we are finished for today.